If the entire solar system were pulled toward this object, it wouldn't even survive the journey. It would disappear long before reaching what lies at its core. According to current theories, something this massive shouldn't have formed so early in the history of the universe. Astronomers have spent decades searching the deepest regions of the universe, studying objects so distant that their light began its journey billions of years ago. Most discoveries appear exactly as expected. This one didn't. Far beyond our galaxy, telescopes detected a source of light so powerful that it immediately stood apart from everything around it. At first, researchers assumed they were observing a familiar type of distant cosmic beacon, but as measurements improved, a problem emerged. No known object should have been capable of producing that much energy. The light pouring across space rivaled the combined output of more than 100 trillion suns. Yet it appeared to be coming from a single location, hidden behind a blinding wall of radiation. Scientists began running calculations to determine what could generate such an extreme amount of power. The answers made little sense. Again and again, the numbers pointed toward an object so massive that many researchers initially assumed there had to be an error somewhere in the data. There wasn't. By the time astronomers cataloged the object as TON 618, the mystery was no longer the light. It was whatever was hiding behind it. And according to every calculation, that hidden object shouldn't have been possible. The light surrounding TON 618 was only the first clue. Once astronomers uncovered what was producing it, they were forced to confront a black hole so extreme that it challenged the limits of current theories. The object hidden behind that wall of radiation was a black hole, but not the kind most people imagine. Black holes themselves produce no light. If TON 618 were sitting alone in space, it would be almost impossible to see. What astronomers detected was the chaos surrounding it. A vast storm of gas, dust, and stellar debris was spiraling toward the black hole. As that material fell inward, gravity squeezed it into an increasingly violent whirlpool, heating it to extraordinary temperatures. Before the matter vanished forever, it released an enormous amount of energy. Astronomers call such objects quasars. In fact, quasars are among the brightest phenomena in the universe, capable of outshining entire galaxies. At last, the mystery of the light had an explanation, but the explanation revealed a new problem, because the brightness of a quasar is not random. It acts like a clue, revealing the scale of the object buried beneath the light. And when researchers used TON 618's brightness to estimate what was lurking behind that glare, the results were difficult to believe. Every calculation pointed toward the same astonishing conclusion. TON 618 belonged far beyond anything astronomers expected to find. The calculations were now pointing toward something extraordinary. The only question was how extraordinary. When astronomers finally estimated TON 618's true mass, the result forced them to create an entirely new category of black hole. Estimating the mass of a black hole is not as simple as putting it on a scale. Instead, astronomers studied the behavior of the matter surrounding it. The speed of the gas, the energy being released, and the brightness of the quasar all provide clues about the object hidden at the center. For TON 618, those clues kept pointing in the same direction, again and again. Independent calculations produced the same result, results so extreme that many researchers initially assumed something had gone wrong. There wasn't. The black hole appeared to contain the mass of roughly 66 billion suns. To understand how enormous that is, consider the black hole at the center of our own Milky Way. Sagittarius A contains about 4 million solar masses and is already powerful enough to dominate the motion of stars across the galaxies. TON 618 is in an entirely different league. Its gravity governs a region of space so vast that familiar comparisons begin to break down. The boundary surrounding the black hole spans a scale that is almost impossible to visualize. That was why astronomers eventually stopped describing TON 618 as merely supermassive. The word no longer seemed adequate. A new label emerged: ultramassive black hole. But Even that astonishing size wasn't the discovery keeping astrophysicists awake at night. Black hole with the mass of 66 billion suns was already difficult to explain. The real problem was when it existed, because TON 618 had somehow reached that size when the universe was still far younger than current theories say should have been possible. The farther we look into space, the farther back in time we see. Light does not travel instantly. Every beam captured by a telescope has spent years, centuries, or even billions of years crossing the universe before reaching Earth. That means astronomers are not seeing TON 618 as it exists today. They are seeing it as it existed more than 10 billion years ago, and that is where the real mystery begins. By the time the light we observe left TON 618, the universe was only a fraction of its current age. According to standard models, black holes begin relatively small and grow gradually over time, feeding on gas, consuming stars, and merging with other black holes. Yet somehow, TON 618 had already reached a mass of roughly 66 billion suns during this early chapter of cosmic history. That creates a problem astrophysicists still struggle to solve. Even under extremely favorable conditions, many growth models cannot explain how a black hole could become so enormous so quickly. Something doesn't fit. Either TON 618 grew far faster than current theories predict, or our understanding of how the first giant black holes formed is incomplete. And despite years of research, no explanation has fully solved the puzzle. Astronomers have proposed several explanations for TON 618's existence, but every solution creates new problems of its own, and some researchers now suspect that understanding this giant may require rethinking how the first black holes formed in the early universe. To explain TON 618, astronomers have proposed several possibilities. One idea suggests that some of the earliest black holes may have started far larger than expected, forming from the direct collapse of enormous clouds of matter rather than the deaths of individual stars. Another possibility is that conditions in the young universe allowed certain black holes to grow at extraordinary rates, consuming material far faster than current models normally allow. Both ideas could help explain how a black hole became so massive so quickly, but neither explanation fully solves the problem. Each answer creates new questions, and that is what makes TON 618 so important. Every attempt to explain it leads back to the same unsettling possibility. Somewhere in our understanding of the early universe, a crucial piece of the story may still be missing. TON 618 is more than a record-breaking black hole. It is evidence that nature may have found a path our theories have yet to discover. More than 10 billion years later, its ancient light is still reaching Earth, and hidden within that light is a reminder that some of the universe's greatest mysteries are not waiting in the future. They have been staring back at us from the distant darkness all along. At the beginning of this story, we imagined what would happen if the solar system were pulled toward TON 618. But after years of study, that is not the question astronomers are asking. The question that remains is far stranger. How did something so enormous appear so early in the history of the universe? Because the true mystery is not how bright TON 618 is, or even how large it became. The true mystery is that TON 618 exists at all.